Hello, my name is Lance Parrish from Team 8372 Trial and Terror, and today I'll be talking about how to have a rock-solid control system, including ESD prevention. Let's start off with some general tips about electronics. So you should always carry extra batteries, fuses, and wires, because especially in a tournament setting, you'll never know when one might break or a battery might run out of power. This goes for both you and for helping other teams. Always separate your data wires from your power wires, and in general, keep your wires organized and well kept. And I'll talk more about insulating your wires later. Make sure the firmware of the controllers is updated. So you want your phone app versions to match, otherwise you'll have problems connecting. And if problems occur, such as problems connecting the phones together or high ping, restart both the driver phone and the robot phone. So this is an example of comparing the different versions of each phone from the driver and the robot. So you want both the app version and the library version to line up. So what is ESD? ESD stands for electrostatic discharge. So when your robot's moving around the game board, it generates electrostatic energy, which can be discharged when it hits a piece of metal, such as a field element or another robot. So signs that you're having ESD problems are disconnects or power downs after touching another robot or metal field element. And a way to test it is you can run your robot a little bit and then turn the lights off and touch your robot with a piece of metal channel. And if an ESD discharge occurs, sparks will be visible in the dark. So don't run your data wires directly against the metal or even too close to the metal. In fact, we recommend about 3/8 of an inch away from the metal, because otherwise the energy will jump into the data wires and cause a disconnect off the metal channel. And practice without your ESD spray on the mat. Although some tournaments will use ESD spray to help reduce these events, not every tournament does, so you always want to practice for the worst case scenario. So this is an example of Hotwired's robot from the 2016-2017 season. They covered up any metal areas on their robot that could cause a discharge when they hit another robot, and they used electric tape to do this. And this is one of the ways that you can help insulate your robot and prevent ESD events. So moving on to some wiring tips about electronics. So you should use Anderson power poles for connections that are frequently unplugged, such as your battery. And Anderson power poles are better than the Tamayas or the XT60s because you can plug them in and unplug them a lot without causing any wear or tear, while with the other ones, it often results in the connections not working. You can use bicycle tubing to insulate wires from metal, and we'll show you examples of that in picture form. You can use zip ties, self-adhesive cable tie-mounts, grommets, and drag chains to secure and protect wires. And we used a lot of these, especially last year when we were extending out to grab something and we needed a servo on the end. So make sure your wires are secure because it's not a good idea to damage a lot of them. Keep your wires as short as possible. So you don't want really excessively long wires so that they become tangled and move in aspects of your robot. And it's a lot easier to organize if you prefer to use shorter wires. And you need a regulation on-off switch. So FTC actually lists the switches that are legal for tournament play, and you always want to make sure that your switch is regulation. So moving on how we protected wires on our robot from last year. We used an Anderson power pole, as you can see on the left, as it was a better connector that wouldn't break so easily as the XT60. And we also used adhesive cable holders, as you can see on the middle left, so we wouldn't run our wires directly against the metal, which would cause ESD events. Then on the right, you see an example of us using zip ties and bicycle inner tubing to insulate our wires once again. Then on the far right, you can see us using grommets to run wires through the channel. So this is an example of how we used a drag chain on last year's robot to protect the wire. We never really had any problems with this wire, even though we extended it quite a long amount because of our use of the drag chain. So strain relief. So strain relief is basically referring to your actual hub, which is either your modern robotics or your Rev Robotics hub, and the cables that go into that. And when they unplug, they can cause disconnects. So for modern robotics, the strain relief we used was a combination of 3D printed parts and zip ties, so that the USB connectors wouldn't fall out easily, which is what they would normally do. But for the Rev Robotics hub, you actually have a USB retention mount that you can buy separate of the hub, which is pretty useful for preventing disconnects. We also used a custom 3D printed phone holder to help protect our phone and the wire going into it. And on the left is the example from last year's robot. And on the right, you can see that we uploaded this design onto Thingiverse, which is basically a hosting site for 3D printed designs. And you can, we have a link to it at the end that you could look into if you are interested. So this year specifically, we had some issues with ESD and ESD disconnects, especially at some of the earlier tournaments. So what we used was an ESD gun, and this ESD gun would basically shoot electrostatic energy into a specific part of the robot that we touched the gun with. And using this, we found out that our phone cord was the major problem, and this was because it was generally running pretty close to the metal channel. So we installed what is called a ferrite choke, which basically prevents a huge amount of electricity from traveling through the phone cord, and this has really helped us prevent ESD events in the future. Moving on to some programming, basic organization. You should always comment your code, even if you're the only person coding on the team, but especially if you have other people working with you. Not everyone's going to understand exactly what you changed or what you did with your code. Even you, if you're looking at it later and you're wondering what you changed that made the robot not work anymore, it's always useful to have a comment. Keep your SDK, software development kit, up to date. This will save you a lot of headaches, especially with Android Studio, which takes quite a while to update in some cases. And you can use a program called Git to keep track of different branches of your programming. So Git, it basically allows you to have a main branch, and then for each person working on the project to have their own development branch. And although it's a bit more complex than that, you can look into it yourself if you're interested. So moving on to testing, you should test each new addition to the programming multiple times. Just because something works one day or twice in a row or 3 times in a row doesn't mean it will work consistently in a variety of different scenarios, especially at tournaments. Don't change multiple parts of the program at once. For example, if you're programming autonomous and you change 2 things about the autonomous and then it stops working, it'd be much more simple to just change one thing at a time and then evaluate if the autonomous works. Program different autonomous programs for different scenarios. For example, this year, if you know your partner cannot take the mineral off and score those points in autonomous, then you might want to program for a scenario where you take their mineral off. And finally, just test as much as possible. Although you won't be able to prepare for every possible scenario, you can really help your chances of success and your consistency. So moving on to coordination involving the build team. So the build team, drive team, and the programming teams must communicate amongst themselves. The programming team can't just change some part of the teleop and then not tell the drive team, which results in a lot of confusion. And the build team must consult the programming and drive teams about adding something to the robot. And generally, a system that we found successful was that the build team should finish any major changes to the robot 1 week before competitions to let the control team work on autonomous and to let the drive team practice driving. So, moving on to the protection of your electronics. You should cover any exposed electronics with Lexan, which is what our team used, and it's worked incredibly well. But keep in mind that you should keep your electronics easy to access and replace in the event of a broken wire or some other disaster. So, tournament checklists. So both the drive team and the pit crew should have checklists. So the pit crew, the people who are getting the robot ready before you do your match, they should check the drivetrain gears, make sure all the motors are fine, servos are fine, and that the batteries and phones are charged. So the drive crew in the match itself, make sure the robot is correctly set up on the field, and make sure that the robot is actually turned on. And although this seems quite trivial, last year we had a problem with it where I was sitting on the sidelines watching as the match started and our robot did not move at all. So I asked the drive crew what happened, and they said that when they plugged in the phone, it turned on the light of the rev expansion hub, but it wasn't actually turned on. There was no power between the battery and the hub, so our robot did not move. So these are some further references for if you're interested in wiring or electronics. So the FTC wiring guide will really help you. Just read through it, skim through it. FTC Tech Talk, that helped me formulate this presentation, will give you tips for performing well at tournaments. So our Thingiverse, which has some of our designs, such as our 3D printed phone holder. ESD chart, which will show you how well certain materials do with ESD. And thank you.